So, hi everyone, welcome. This is the how to Nixify your code base. And I do have a very tab-inspired subtitle. My name is José Storopoli. You can find more about me at storopoli.io. I work at Open Labs. We are building a zero-knowledge Bitcoin native rollup. It's called Strata, and if you want to take a look, go to openlabs.io to find more about us. The slides, it's pretty much like a markdown file, and you can grab those at this URL here. I'm going to pause a little bit here so that everyone has the URL. It's reduced.to/MV, so Mike, Victor, Quebec, Kilo, Hotel. And if you, by any means, cannot type this, go to my GitHub profile, which is my last name, which is also hard to type, but it's one of the latest gists you can find there. So, but I think everyone can access this, right? This link is not broken. I tested today. Okay, great. So let's give a couple seconds for folks to type that in. And please, if you don't have Nix installed, I'm going to show you how to do it, but you should have done that before coming here. I know that nobody reads the issue for the thing, but it was one of the things that I highly recommend you guys doing. Okay, I'm going to move forward. If someone needs the link as well, let me know. Then I'll come back here. So what is the agenda for today? I'm going to be like sitting down because I need to do like copy and paste and running code, so it's easy to do that. First of all, I'm gonna go over why Nix, why makes it unique, some basics of the language. This is I just put like placeholders of 5 minutes, but this is just like a quick rundown of the basics. I'm gonna show you what is a Nix derivation, what is a flake, how to run Nix both locally and also in CI. And the bulk of the workshop, we are going to do a hands-on and build your own flake. We are going to follow like a very simple flake that I did here. But this will enable to start tinkering, kind of like a kickstart for you to use Nix and get acquainted with a Nix flake. And then we are going to do a wrap-up, like some final questions and maybe some feedback. But feel free to raise your hands, interrupt me at any time. We do have a mic here. We are recording this to YouTube. So if you guys don't want to have your audio in the recording, just say something at the mic, and I'm going to say the question was that, and we'll follow through. So first of all, why Nix? What is the issue with Docker, virtual machines, and what are the limitations? So Dockers and VMs, they do isolate the environment, but they don't have precise reproducibility. And here's an example. Every Docker image at some point has something like run, sudo, apt, install something. And that is not reproducible because if you are at a different point of time or space, if you are in another continent and you hit another CDN or another mirror, you get a different version of the package. Or if someone did this yesterday or 1 month from now, they get a whole different system. In the day-to-day, that might not be an issue, but if you want fully reproducible environments, this is not good enough. Yes, you can do that, like log files with Docker, but it's not the default. The default in Nix is everything being reproducible. We do have some issues of works on my machine and some dependency hell in Docker, but that is not the major, that is not like the primary experience, but sometimes you might get this issue in Docker. And what Nix brings, so folks who like functional programming, this is a pure functional programming. There is no impure functions, no side effects. It is reproducible. Every build is guaranteed to have the same environment everywhere. And it's immutable. It's a functional programming, pure functions, so it's immutable. by design. And finally, has native support for Apple Silicon, Apple Intel, ARM Linux, or Intel Linux as well. And I might need to reduce the zoom here, yeah. And there is like a bunch of reliability. You don't have what is called about environment drift, so things changing. And you get reproducibility at both system level, but also at the package level as well. And it's perfect for Bitcoin projects because we need to have a reproducible system and we need things to not shift underneath us for all of the Bitcoin projects. Some language basics. I really gonna defer this for you to do your own research. Go to like a Nix wiki and figure out the language. It's not that hard. But here are some aspects you define. It's declarative and lazy evaluate. That means that you define what you want, not how, so it's not imperative. You just say, I want this, I want that. It's lazily evaluated. You can specify a bunch of things, and if you don't need those things, they will never be evaluated. They will never run, so it's lazily evaluated. And here's a very simple derivation. We're gonna go over derivations in the next slide, I think. But for example, this is a Nix derivation that takes as input a set called packages and outputs another derivation, which is pretty much I'm making a shell. It outputs a development shell that has the package hello world from the Nix packages, and this is a very simple hello world in Nix. It's functional, so the values do not change after definition, because you don't have side effects. And you can compose, it's modular, composable. You can compose small functions to build larger systems. You can compose modules and link them together and so on. And that's kind of like the language basics in a nutshell. Everything is an expression that it's lazily evaluated. We have some data types, the basic ones like strings, lists, sets, which is similar to dictionaries if you come from Python, or hash tables if you come from the Java world and so on. And this is exactly like an expression in Nix. I'm declaring variables and I'm seeing an expression here. And if you grab this thing here and you go to a Nix repo and you copy and paste this and you execute, you get hello world. So it's that simple. The language is very simple, but it enables you to build more stuff upon it. So let's go over what is a derivation. So a derivation is kind of like the fundamental unit in Nix. Everything is derivations if you kind of like squint your eyes a little bit. And what a derivation is, it's a recipe for a package or an environment or anything or any other thing also, but mostly we use for packages and derivations and environments. And it specifies how it's built, what is the inputs and what is the outputs. So here is a derivation. We are using the make derivation function from the standard environment. And it specifies stuff like package name, version, the source files that you need for that derivation, the build inputs, and then you have like several phases. You have the build phase, you have the install phase, the pre-build phase. There's like a bunch of those, but mainly you're gonna need at least one build phase or one install phase or both of them. And here's a very simple like make file derivation where the build phase is the command make and the install phase is make install. So this is how you pretty much plug and play Nix derivation on top of a project that has like make files, for example. And the important thing is that the derivation is run in a sandbox environment that has no connection to the outside world. So there is no like curl this into that and so on. So there is no internet access, and you specify all of the inputs if they need to be fetched from the internet or from some Git repo or from GitHub somewhere, and then you lock it down with a hash for the whole derivation. And Nix is gonna fetch everything, run the derivation like phases, and if there is an error, it will show the error. But what's really nice, if it builds correctly, then you are ready to ship it natively for all of the target architectures that I just said, like Apple Silicon, Apple Intel, and so on. But it's really important for you guys to know that you don't have internet access. So you cannot say, yeah, just run this. You cannot say something like, instead of make here, you just say, no, just run curl something and pipe it to bash. It's not gonna work because there is no internet access. You need to make it as an input. And the input needs to be hashed because it needs to have some sort of integrity as well. We need the inputs, the dependencies that we need, how to compile the package, that's the build process, and the outputs, what gets produced, binaries, libraries, and so on. As I said, it is isolated in a sandbox environment with no internet access, and that's kind of like the anatomy of a Nix derivation. So let's go over to a flake. A flake is a way for us to standardize the interface for Nix projects. And it's really nice because it's reproducible and composable. Reproducible because every flake has a log file with the hashes of everything that it uses as inputs. And also composable because since it has inputs and outputs, we can use flakes to build other flakes. So for example, your flake outputs something that is an input for another flake and so on. And you can, a lot of GitHub projects has flakes. If you see a file called flake.nix, it's pretty much a recipe of how to use that project or that package or that library as a flake in your Nix project. So you'll probably have seen some flake.nix in some GitHub repos. This is what it's doing. And a flake has kind of like 3 fields. The description, which is pretty much a string, that's some metadata, what this project is about. And then you have 2 other, the inputs and the outputs. What this flake takes as inputs, this could be like a bunch of things, could be like a Git repo, another flake, could be a Nix package repo as well. And you can version control those. So here I'm tagging 4.05, and Nix follows kind of like a bi-week, every two releases per year. So on May and on November. So the next one is going to be 24.11, maybe next month. And then in the outputs, pretty much you say what it takes as input. So here it takes the Nix package, and the package that it's going to build just a Linux AMD architecture package, and this is going to be the default. When you call like Nix build or Nix run on this flake, it's going to output this one, and it's just going to output a shell with the hello world Nix package available for you. Yeah? Yes, the mic is over there. I think you need to turn it on, maybe.
Test, test. So you said no internet access, but the input's a URL. So does that mean you're allowed to use the internet to set up your inputs and then no internet while you make it?
How it works is that it will fetch all of the inputs before starting the sandbox environment for building stuff or for running stuff, or for building your environment. So all of the inputs, they need to be declared. You cannot have like uncertainty or undefined behavior. So you cannot have something that does a wild curl and grab something that might change. So you can specify anything as input, but you need to specify. And it needs to go either through these inputs here or through those, in the derivation, through those build inputs here. You cannot do something like, okay, in the phase, just do a curl, get this and that. It's not going to work. You need to like specify in the inputs. Then it's going to fetch it before the recipes for the derivation. Does that sound more clear for you? Great. Yeah, it took me a while to figure that out. I was like, why this is failing? It works in my machine, but it doesn't work on Nix.
I have a question. Well, feel free to defer to later, but since we're on flakes, I was curious if there is a way to hide certain flake inputs. Let's say, for example, like if I put my config online, but let's say part of my flake inputs might be like fixed Bitcoin project, but I don't want people to know, to target me. Is there a way to like hide that as a secret, or by the virtue of using flakes, that is going to be somewhere in your repository, like in the lockdown?
I mean, one thing that you can do, yes, it's going to be in your log file. So one thing that you can do is you can git ignore it. So suppose you have like a config.toml that has sensitive content. You can do a git ignore on that one. You can provide in your flake a config.toml.example. So it's a template. And on your flake, you on your local repo, since it's git ignore, you pretty much know that that file is there, and you can specify that file in your flake, in your local flake, and with the SHA of the file. So if that file change, the SHA will change and the derivation will fail because the inputs don't match the SHA signature. You can do that. And just be careful, because if you do that, you might generate a flake log that might leak some of the contents. So just be aware that you also need to be extra careful with committing flake logs if you have some sort of like git ignored config file that has sensitive content.
Okay, but it sounds like the solution is to not.
Yes, I will do that.
Like, for example, I know there's a project called like Nixify, and that allows you to like encrypt private aspects of the configuration. But it sounds like as far as flake inputs, that goes beyond the scope. No way.
You can do that, but I use it. I don't use SOPs. I play around with SOPs, but I use AGE Nix. You can use AGE Nix as well. And there is a way for you to do that as a flake input, as like a flake something. But go to the AGE Nix repo and check that out. This is beyond the scope of the workshop. But there is a way, and yes, you went in the right trail.
Okay,
yeah.
Appreciate it.
So the flakes, it has like the inputs. Typically, you grab those from like Git repo, and outputs could be like packages, whole system configurations, because Nix is kind of like a meta thing. It is a package manager, it is an OS, it is a way for you to do like environment, reproducible stuff, and so on. And you can also build apps with Nix. You can do, as I said, the flakes allows you to like compose a lot of things and guarantees reproducibility. And that's pretty much it about Flake. We're gonna build one from scratch right now. But before diving into that, I'm gonna touch base on how to run Nix locally and in CI. First, you need to install Nix. It was one of the prereqs for this workshop if you want to follow along. Use the deterministic systems Nix installer. Careful, this is a curl to a bash pipe. So it's gonna run arbitrary code from some dude in the internet in your machine, so check that first. And once you are good to go, you should have like several commands like nix develop, nix run. You might need to restart your shell because to load like nix, put it in the path file as well, and in the path environment variable. And you should have stuff like nix develop, nix run, and nix build as well. And how you do it is pretty much you do like nix develop or nix build, and if you do dot, this is going to be like the current directory, and by default it's going to go to the default recipes. So if you do nix build dot, it's gonna build your default package.
So this is the Nix shell. It's not Nix OS. It's Nix shell. What you're doing.
This is Nix shell. This is what I'm doing. Nix develop will get you a Nix shell. And we are going to go over this during the workshop. We are going to build a shell and a package. And I'm going to show you how to do that. But when you do Nix develop something, you want environment. You want a development shell. So an environment that has all of the things that you need. If it is like Bitcoin D running, it has Bitcoin D running with all the configurations that you need. If it has, if it needs something, I don't know, if it needs to spin up a bunch of things. So, for example, Fed means there's kind of like they have like a Nix crazy thing that if you do like Nix develop, it's going to spin up a lot of things. It's going to drop you into a Mprox console with a lot of things running, kind of like a matrix, like screensaver, and boom, you are good to go. How to do this in CI? It's really easy because this is like a very basic how to run Nix on CI on GitHub Actions. You pretty much do the classic check out the repo, and then you install Nix using the determinate systems Nix installer action. And there you go. You have Nix ready, and you can do like Nix build or Nix build some other thing if you want to. And this is pretty much how a lot of packages and a lot of projects they deal with testing Nix stuff in CI.
Yeah.
And I think this is almost my last slide because before we dive into like some code and running stuff. So how we're gonna do it? We're gonna build. So this is now the bulk of the workshop. Let's build a flake together. It's gonna be a very simple Rust project that runs a Bitcoin D command. Why Rust? Because I know Rust, so I can help you. I'm not very good at JavaScript. Actually, every day that I don't touch JavaScript is a good day for me. So, but you can do this whatever project you want. You can do this for Haskell, Nix, Python, JavaScript, all other languages. Nix is available. You have templates. So, okay, let's start. And you don't even need to have like Rust installed. You just need to have Nix installed for this workshop. So let's copy this. This is the classical cargo init. So go into a directory, create a new temporary directory, cd into that, and then just run this. Nix run, Nix packages. So I'm gonna run the Nix package derivation, but I'm gonna run the cargo package in that derivation, and I'm gonna run with the cargo init command just to create like a Rust binary. And if I do this, oh, come on. Oh, sorry. Cargo, and then you do init. There you go. I double type it cargo. I'm gonna fix that later. There you go, and if we do like an ls, we have do I have 3 here? Yes, I have 3. There you go. We have a cargo tunnel. I have my slides here, so ignore that. And we have like a source and main. And if we open, if I type it, if you open source and main, we have like pretty much like a hello world here, and it works. So this is our basic cargo new something, but I just did in a directory, but you can do that. Cargo init if you have already a directory ready to go. Okay, and if we do something like cargo run, this should work. There you go, it works. So we don't even need to have like Rust installed. We can just call Rust or cargo from Nix as well. Yes. Yeah. This second cargo does not exist, so it's just Nix run, Nix packages, cargo init. And since we are like ahead of schedule, I'm just gonna go back to the slides URL so that everyone has this. Come on, there you go. These slides, they are on a Markdown file in this link here, so it's reduceit.to. / Mike Victor Quebec Kilo Hotel. And this should redirect you to a GIST. And the markdown files, they have all the code that you need to run, so it's way easier to copy and paste from that file than copy and paste manually from like a random screen a couple feet away.
I don't think much about actually.
The what?
I don't expect it.
Does anyone have any issues with the cargo package with this command here?
Yes.
Yeah, it's going to take a while because you need to download it. But have you tried Nix one, Nix packages? How do you install Nix? Yes, so depending on how you install Nix, you need to. I advise to use the Nix Dependency Systems installer, and the Nix community is debating. They will probably make this the official installer because it enables extra functionality, which is the Nix commands and the flakes, and probably you are missing that one. So you need to go to the etsy Nixconf and just Google how to activate Nix command, and I think you already have expert help with you. So yeah. But this should run, right? I'm not going crazy. Without the extra card. Yeah, this Nix package cargo one should run, right?
It's like 44 megabytes downloading right now.
Yes, it's gonna load the whole like archive of the Nix package's latest archive snapshot, and then it should run in a couple seconds. Just this second cargo does not exist. It was a typo. Actually, I'm gonna fix that. Did it work?
Yes. Okay, cool. Help us well.
Okay. So let's open our main file. Let me reduce the. I need to reduce a little bit here. There you go. Let's copy. Oh, this is going to be painful. Okay, I'm gonna do like this. Actually, this is not gonna work either. 1 second. There you go. I have it here, so I can copy this guy here. So let's open our main here, and let's paste everything. So what is this code here doing? Since I'm running this in a very lightweight virtual machine, a VPS, I don't want to have external dependencies. I don't want to deal with cargo compilation versus compilation. So this is just going to use like the standard library. It's going to like output Bitcoin CLI command, get blockchain info, and it's going to pipe to the standard out. And it's going to grab the standard out, pipe it to a string, and then it's going to print out the string, something like output from Bitcoin CLI and the output string. This is pretty much it. Yeah?
Yeah, installed.
No. The question was, should we have Bitcoin DE installed and run it open? No, because Nix will handle that first. And that's exactly the point. If you run this, it's going to fail. And how do we fix that? We fix that with Nix. Because then you will force everyone to, go download Bitcoin and install Bitcoin in your system and do this and that. Whereas the purpose of this workshop is say, hey, this is the flake, and just do like Nix run, and all the dependencies will be handled in the Nix configuration. Well, that was a great question. Thank you.
Thanks.
So, okay, this is our file here. I don't think that anyone has any questions. A simple Rust script that calls Bitcoin CLI with the branch test option, get blockchain info, and then pipes this to the output, and then just puts the output. Now, if I do the cargo run, it's going to fail. There you go, it failed because we don't have Bitcoin being installed. So how do we fix that? We run it and it's going to fail. And how do we fix this? We grab one of the flake templates. There is a lot of those. There is like Nixify templates, this GitHub repo that has tons of those. You can also go to the Nix community, flakes templates as well. They have like templates for everything. Everything that you can think of, they have templates. JavaScript, TypeScript, Python, Haskell, Rust, Go, whatever you want, they have templates. I'm gonna grab the trivial template because we're gonna build upon this. So I want a very like thin stuff that we can delete and build it from scratch. So let's copy this guy here and run here. So now if we do a tree again, oh crap. Let's do an ls. So now if I do an ls, I have like one new file called flake.nix. And if we open that file, we have pretty much descriptions, inputs, outputs. Everything that we just saw that a flake needs and a flake has are those three things. So we can start changing those. So let's change the description. I don't know, my awesome. There you go. My awesome Cyberpunk Bitcoin project. And I'm going to use as input NixOS unstable. So, but of course here you can lock it to like 24.05, 24.11, and so on. If you don't want to YOLO and leave on unstable Nix, it's not that unstable, but yeah, you might want to not go unstable. And what is this trivial template gives us two derivations. So gives us two Linux derivations, which I'm running Apple Silicon. It's not going to work. So the first thing that we're going to do is fix those things. But it gives us hello. So this is pretty much like a hello package. And it gives us a default derivation that just points to the hello derivation. So this gives us just one derivation. This is what the flake is doing. Any questions so far? All right, let's change this a little bit. First thing that we are gonna do is, actually, I'm in a Mac Silicon, but I'm in a Linux VM, so this might work. So one thing that I can do is I can quit and I can do a Nix run like this, and this should work. Oh, sorry about that. I thought that I had already downloaded that. So this will work in my machine, but probably in your machine won't. Not all machines will work because, as we saw, this is hard-coded for x86 Linux, and if you're running like ARM Linux or Apple Silicon, or maybe you are one of the crazy guys that is running a RISC-V, it's not going to work. Let's wait a little bit. There you go. And while we wait, do you have any questions, comments? Yeah.
So I guess can you talk more about how you handle the different architectures then within the flake? If you have these competing things, everybody's on an M1 or M2 or something like that, and you're deploying on.
The very next slide. That's a great question. So, yeah, this would work in x86, and let's see if the command, okay, it's still running. But the problem is that we need something that pretty much works in all architectures. How do we do this? We have a company called NumPy. They are like very hardcore Nix people, and they do have flake utils which is a flake that provides a lot of utilities, and one of those is the each default system. And this function, it takes like any system and outputs derivations for that system. And what we are doing here is, in the outputs, we are wrapping this into a functional, into a function. Remember that Nix is a pure functional programming language. So what we are doing is, we have like each default system, and now we are grabbing a system, and for any system, we are defining a Nix package as packages, and we are inheriting that system. So if this is like an Apple Silicon, this is going to be like Arch64-Darwin. If this is like a Linux AMD architecture, it's going to be like x86, 64-Linux, and so on. So this is going to like create a Nix packages derivation specific for your environment, and also it's going to output a default package for your environment called package.hello. So if we copy this, this should work. Let's just take a look, okay? Now if I do Nix run, it works. And if I do, of course, I know x86, we're gonna fix that for Apple folks. So if I do Nix build, yes, it's gonna build. And now we see that when you build, we have a result. So if I do a tree result, oh, that was not good. Okay, so let's do ls result. We get pretty much the derivation, which is the package hello itself. And the package hello itself has a bin subdirectory and a shared subdirectory with like man pages and so on, because it's a Nix package. And if we pretty much do like a result, a bin, and here we have only one binary hello, it is the same thing. So we can both run a derivation, but also build it into a special result directory. This is what the Nix run and Nix build command do. Now let's fix this. Let me grab my code here. There we go. Oh, hang on. I want my description. My description is being nice. I don't want the other stuff.
Well,
so let's change our flake again. Come on, flake.nix. There we go. So let's grab those things.
all right.
Copy those in. And if I'm not copy paste wrong, this should work. So just to recap, we get the flake util. So this is gonna add one input to our Nix. And this is a nice place to show the flake.log, maybe. So here's the flake.log. So as you can see, we have a log file of all the inputs. So if we are using the Nix packages input, we have it here. It's we have like a timestamp when it was last modified. We have a hash of the state. So this is fully reproducible. We have which GitHub owner is this. This is the NixOS, which repository, the commit that we are pushing from. And this is a GitHub repo. And we get some metadata. And let's go back. Now, marking this. So now we are adding a new input. So we are gonna have a new input in our log file. We can take a look later. And this is going to like create everything. So let's see if this works. So let's do now Nix run again. And there we go. It just printed for us that it added inputs, utils, and util systems, and so on. And there you go, it works. And it should work also in your Apple Silicon or any other architecture apart from x86 Linux. Okay, let's just take a look at the flake.log real quick. And as you can see now, we have like new stuff. We have the Nix packages here, and we also have the system and utils. These are the two inputs that maybe the flake that we added brings to our flake, to our local flake. which is our awesome cyberpunk Bitcoin project flake. So that's how the relationship between Nix, flake.nix and flake.lock works. So let's move on. Okay, now, what do we need to do? Let's first add a development environment. How we do this is what we need in our development environment, we need Bitcoin running in Rest test, because that's what our package is doing. It's calling like a Bitcoin command from the main function in our main binary in Rust. So we just add this in one of the derivations. So one of the derivations, dev shells, this runs when you do Nix develop. When you do Nix run or Nix build, it's gonna run one of the packages derivations, outputs. But when we do Nix develop, it's gonna run one of the dev shells once. So let's go ahead here and copy this guy here. And let's open again our flake.nix. And now I have a new derivation. We had the default package, I'm gonna add a new one. And this is the dev shell. And what I'm doing here, I'm saying, okay, I need a development environment that is a packages make shell. And what it takes is, it takes a build inputs. So I need cargo and I need Bitcoin D. And Bitcoin D is available. Bitcoin CLI, Bitcoin D, Bitcoin, and Bitcoin, which brings everything. They are all available in the Nix packages. So if you want to find a package, you go to search.nixos.org. So let's say, let's go package. Which package do you guys want?
LDK.
LDK. LDK, it's a TLA, so it's going to be hard. But it is there somewhere. I don't know. Which one you said?
I said Moped browser.
Oh, Moped.
Sorry.
There you go. Moped is easy because there's like way more strings. It's not that TLA. TLA is 3-letter alphabet. So there you go. We have like Moped VPN, Moped browser. There you go. And if you click on this one, it's gonna show you, hey, if you wanna like Moped, you just do like Moped browser. If you wanna put like this in an XOS configuration, there you go. Packages, oh, let me zoom in. Packages Moped browser. So you have like tons of those packages there, and you can use any one of those. You can also use other flakes as inputs. Don't forget about that. So we are adding cargo and Bitcoin D, and we have a shell hook. And whenever I instantiate this shell, I need you to run some stuff, because it not only suffices us to have Bitcoin installed, it needs to be running, right? The daemon needs to be running. So the shell hook is this is a Nix multi-line string. So single apostrophe, single quotes, double single quotes. It's like a multi-line string in Nix. It's like triple double quotes in Python. And this fancy thing is that I'm doing like a string interpolation. So I'm grabbing here whatever is run whatever you are storing the packages Bitcoin D, replace here for that file path and /bin Bitcoin D. And you can find like all of the stuff that is inside the derivations if you go under like the Nix packages, and if you click on source. So if you click here on, where is the source? Here, source, you go there. So, and here you just like inspect the source, and here you see that they do have somewhere here like something that will show you where's the bin. There you go. You have like a binary here. There you go. This line here. You know that the derivation has a binary subdirectory. So that's most of those things will have like a /bin, and there you go. We need to run the Bitcoin D binary from the bin directory, subdirectory in that derivation, and we're gonna specify some flags, reg test, and daemon mode, and this should be enough. I think right now, if we save this guy and exit, and if we do cargo run again, well, first, really important, Nix develop, So I run this, and this is going to download Bitcoin D. There you go. It's going to download Bitcoin D. There you go. Bitcoin Core start. So the shell hook worked. Now, if we should have cargo here. Yes, we do have cargo because it specifies one of the build inputs. And if we do cargo run, boom, it works. There you go. We have a dev shell. That's great, but we also need a package, right? Because that handle half of the equation. We have a shell environment, a reproducible environment for development. So this takes care of developers trying to go into your package, but also we need users. So how users are going to consume your package? Now we need to go back to that, like to flake to that package derivation, right? So we need to fix this guy here. Because we want to do Nix hello and having that run with all the Bitcoin D, all the dependencies that we need. So we are going to do this next, but I'm going to pause a little bit and take questions or comments if there are any. Yeah, go ahead.
Now, okay.
I don't. Is that okay?
I think you need
Okay.
Oh, it's okay. It's on.
You mentioned that it doesn't have internet, so how do we like have to continue with that? Because as you showed, that the people like it doesn't sync with the like blockchain, right?
No, this is reg text.
Oh, okay. Wait. So it's only when you are running the command they are not connected to the internet, and now they can connect to the internet or no?
Only derivations, they are run in a sandbox environment.
Yeah.
So to build this shell, this developer shell, I don't have access to the internet.
Yeah.
So if here I do something like curl full, then I'm screwed. This is not going to work. But once the shell is created, so I'm in the shell, I have it here. So it works.
Okay.
So to build a shell, it's a Nix derivation. And derivations, they have a sandbox environment that they don't have access to the internet. All the stuff that they need to fetch from the internet or from outside, they need to be specified as inputs.
But basically, that the script is the hardware is running, it doesn't have internet, but now it's already run, like the build is already done. Now we have the internet.
Yes, now the shell has internet because to build the shell with all the dependencies to have something like Bitcoin D, yeah. To grab these and to do the shell box, it is a derivation. To build the shell is a derivation, but to use the shell, it is just a normal shell. It has like internet access and everything.
And the fact that I have the plot is not zero is just because this is a local test now, right?
Yes, it's like a rush test.
Okay. Thank you.
It does link that next. Default package that shell with keywords you get like you have shell sig that shell.
Yes, you can. So
Okay. Yes.
So yes, you can. You can specify several of those. I forgot how to do that. but yes, you could do something. So the question was, am I only type one derivation in package and one derivation in shell? No. You can do something like Nix develop full here. And then it's going to like create another shell called full. So you could do that. I might try to do that towards the end of the workshop, because right now I need to cover also the derivations as well, but yes, you can do that.
Why not you do that?
Huh?
Why not you do that?
So, a very good use case is suppose you have like a minimum supported Rust version. You want to have a shell that grabs your Rust version from whatever version you need, and then you can do like Nix, develop, MSRV, and this is something that we even had it working in a working PR in BDK that was trying to Nixify stuff on BDK. And if you run this, you get like everything all set up, all the environment variables all set up for you using the minimum supported Rust version. Or if you do just this, you get like latest stable. So this is a use case. And we had Jordan, yeah.
that in the flake output, what is the difference between building flakes and package field?
So the question is, let me go to my flake again. What is the difference between package and build inputs? So default package is a derivation. And that shell is another derivation. And this is a shell, and this is a package. The shell runs with Nix develop, and whenever you call Nix build or Nix run, it's gonna call the package derivations. And these derivations they can have build inputs, and the build inputs it's the build inputs for the derivation make shell here. Does that answer your question?
But inside the dev shell, you have, for example, build inputs is one property, shell hook is another property.
Yes.
And again, just remember revisit, there's another property packages.
No, they are all build inputs. One thing you can do, you can have something called native build inputs. And you can add stuff here also if you want to. And this is for like stuff that you need to build natively for your architecture, like Python dependencies and so on. Honestly, I don't know very much the difference between build inputs and native build inputs, but it's another thing that you can do it here. Yeah.
One question I have for you is it possible to run a flake through the REPL to kind of like step through what's happening?
Run a flake to the REPL? Yes, but I don't know how to do it.
Okay, but it is possible.
I think so.
Okay, gotcha. And then this, my last question is there a way offline to check available properties? Like given that question we were just talking about with the dev shell, is there a way to check the properties on that?
Yes. No, I don't want to save changes. So if you do like Nix, check, no, it's not Nix, flake. There's a Nix thing that will list all the outputs. I forgot which command it is. Does anyone remembers?
The Nix flake show?
Yes, Nix flake show. There you go. You have everything. So as you can see, I'm building from all the architectures. I'm building for Darwin, for x86 Linux, and here I have a dev shell that will output something, and I have my package is a package hello certain version.
Gotcha. Thank you.
Yeah. So let's move to the final part. Okay, how do I make the package work? So okay, we made the dev shell work. Now let's do the package. How I do this? I'm gonna copy this and I'm gonna go over what I'm doing. So let's go back here. Let's copy this guy here. All right. There you go. Now this guy is out, and we have this guy here, and let me just. It's gonna complain if it doesn't have like the right indentation. Oh. Yeah, this should work. Yes, so. So what I'm doing here is I'm calling a build Rust package. This is defined in the Nix standard library. So this is a Nix package, and I'm giving a name. I'm giving a version, and also this specific build Rust package it needs a cargo log file. And I can also lock it with a SHA hash if I want to. I can even go more thin file hat and lock it with a SHA if I want to guarantee integrity that if this thing changes, the derivation will fail. And source is going to be like my current directory. And Nix is so nice that this thing here is a file path and it's a specific type. And so Nix is built for like reproducible system that the paths is a dedicated native file type because strings are complicated for you to specify paths and directories. And the building points here, I'm doing Rust-C, Cargo, and Bitcoin. I can delete Rust-C because if I call Cargo, Rust-C will be brought with Cargo as well. And the pre-build, what I'm doing is I'm creating a directory called data, and this out here is an environmental variable that will output for the result, the special directory that will be created. So I'm creating a subdirectory data in my result, in the output of my derivation, and then I'm doing the strict interpolation thing, calling bitcoin.d, binary bitcoin.d, rash test, daemon, and the data there is my output data. And that's pretty much it. And since build Rust package handles all of the cargo run under the hood for us, this should work. So are there any questions here? Yeah.
Scroll down, please. Where is default package being used?
It's being used in one of the outputs. So we have here outputs. We have two outputs: the default package and the dev shell. These are the two outputs. They are wrapped around this function here called lead each default system. So this flake will run in all architectures like Apple Silicon or ARM Linux, x86 Linux, and I'm also doing some variable binding here. So I'm saying, okay, every time that you see packages, please use the packages for the architecture that you are running on. So this is like a simple like binding so that packages is correctly binded to your target architecture that you are running this flake. And now the final thing, once this is done, let's do a Nix build. So let's save and quit. Let's do a Nix build. If I type it right here, there you go. And we don't have a cargo log. Oh yes, Nix is annoying. Sometimes you need to do git add stuff. So now it will see the cargo log. This is because flakes, they're tiny, integrated with Git version control. So every time that you have like a crazy error that cannot find something, try to do a git add. Yeah, it took me a couple of days to figure that out on my own, like back in the days. So now we have like a result package, and there you go. We have like a result. We have the data. Before we only have the binary. And now if we run like result bin and Nixify TABConf, remember this was the name of the package that we gave. So Nix build Rust package, grab our main file from Rust, did a cargo run, and outputted the binary name as Nix workshop. And oh no, sorry, this is the repo name. This is the directory that I'm in. Sorry, my bad. So if you run this, there you go, it works. It has Bitcoin running and it works. So, and we don't have Rust installed in this machine, nor we have Bitcoin. All is handled by Nix. And just to summarize so that we can go like to questions and I need to leave the stage in 4 minutes. So just the key takeaways, you can have reliability and reproducibility in Nix, and this is hard to come by. Docker doesn't give you, Terraform doesn't give you that quite enough, and so on. It is perfect for like mission critical and things that you want to have like longevity, like Bitcoin projects. I'm a very big fan of declarative and lazily and functional programming stuff. So this is really good. It's a paradigm shift in how you manage your reproducible environments. It's easy for you to onboard new developers, new contributors. It's easy for your users to consume your package and so on, if you need like a lot of dependencies and so on. And also, we do have kind of like a very well curated and maintained Nix Bitcoin stuff. So the Bitcoin community, the developers there are already like into Nix. So you'll find a lot of stuff in Bitcoin that is already provided by Nix Bitcoin. And that's it. I have 3 minutes for questions and maybe something. Yeah. he raised it first. Yeah. Yeah, so what Nix does is that you have a /Nix directory here, and if you go to the Nix store, this is gonna show like everything that you have that Nix is handling. So all the dependencies for all the stuff that you're running Nix in this machine is here. So somewhere I need a Python 3.12 here. So as you can see here, and Sphinx contribute Apple help. So somewhere in my machine it needed that, and you have like the shop. So Nix is clever that it doesn't build the building ports twice. So it goes over and says, okay, I need this derivation with this hash. It goes over to the store. Do I have this? Oh, no, I don't. Okay, so I need to build it. And then it builds, or do I have this? Oh, yes, I have. It's okay, I'm going to use it. So it's not going to build it again.
Just following up on what you were saying about reproducibility, I was curious what progress Nix has made on source code level reproducibility, like, because sometimes you know how you'll have something depending on something else, and somewhere down the chain, it might just be some binary. And I know there's an alternative project called Geeks that has made work both on like archival of past versions on the source level, but also trying to remove binaries out of the dependency chain. So I was curious if you knew of any Nix-related developments with that.
I mean, this is my final question, but I don't know. We do have something known here, right?
Yeah.
Yeah, so this is my final question. I'm going to take your question offline. So, final question is, so this, if you have something externally that does not use Nix, you can add it. You can say, fetch this binary, fetch this archive, this gzip from here, and the shard is this one. So if the thing changes, your derivation will fail. So you can do that. I don't know if there is like other things. So the quicks thing, I know that it exists, but I never use it, so I cannot comment on that.
Yes.
That's it. Thank you, folks.